over b squared. So we have, first of all, let's simplify this one more time, because 1 plus a squared over b squared is, again take b squared as the common denominator, is a squared plus b squared over b squared. So the integral remains the same, and the right hand side has not changed. So to get the value of this integral, what do we do now? Well, divide by this quantity. And so we get integral 0 to c e to the power of negative ax sine bx dx equal to this divided by this. Is that right? Or when you divide by this, you simply reverse it and multiply. So that's what I've done. So the right hand side multiplied by the inverse of this times b squared over a squared plus b squared. Now b squared and b squared will cancel. There you go. And that gives you e to the power of negative ax divided by a squared plus b squared times b cos bx plus a sine bx. Now this is what this integral looks like. And now what we need to do is we need to take the limit when c goes to infinity. Is that right? Well, first of all, let's apply the upper and lower limit before we go to the limits. All right, let's do that here. So integral e to the power of negative ax sine bx dx equal to limit c approaches infinity. Is that right? We know that we want to find integral 0 to infinity e to the power of negative ax sine bx dx. That is the same as limit c approaches infinity of integral 0 to c e to the power of negative ax sine bx dx. And we have found the value of this definite integral. What is that? Is this. We can now replace this by this. That's right. So that will be limit c approaches infinity of that quantity. Now the lower limit is 0, the upper limit is c. So let's now apply the limits. Take the upper limit minus the lower limit. That will be limit c approaches infinity. Replace x by c. Wherever you see an x, replace it by c for the upper limit. That's what I've done here. Minus, wherever you see an x, replace it by 0 there. So you got the replace x by the upper limit minus replace x by the lower limit. Okay, what does that yield you? We can do a number of simplification here. E to the power of 0 is 1. Cos 0 is, what's cos 0? Cos 0 is 1. And sine 0 is 0. Therefore, this term here will simply be negative 1 over a squared plus b squared times b plus 0. So this will simplify to, tell me what that will simplify to. This quantity will simply be b, and this is 1. So it will be negative b over a squared plus b squared, and the negative will combine to give you positive. So that will simply be b over a squared plus b squared. Alright, so what will this be now? In the limit when c goes to infinity, let's apply the limit here. In the limit when c goes to infinity, this is your c. What is e to the power of negative ac when c goes to infinity? The limiting value of this is 0. Because the limiting value of this is 0, it reduces the whole of this to 0. So the first the first parenthesis, the value is 0, that is the upper limit, minus now the lower limit, where this is 1 and this is 1, so this will be b plus 0, and that gives you b over a squared plus b squared is the value of that improper integral. You see how terrible looking improper integral gave you such beautiful result. Okay, so what we have produced is integral 0 to infinity e to the power of negative ax sine bx dx equal to b over a squared plus b squared. Is that a converging integral or a diverging integral? It is a converging integral. Alright, let's try another one. Evaluate the improper integral. Integral 0 to infinity e to the power of x over 1 plus e to the power of x dx. But again, there are two things I want you to think about before start doing it. First of all, we need to write this as a limit. Secondly, you need to think of a strategy of integrating it. Alright? Think about it. So, write this as a limit. Integral 0 to infinity e to the power of x divided by 1 plus e to the power of x dx is limit b goes to infinity, integral 0 to b of e to the power of x over 1 plus e to the power of x dx. Alright, I have actually given away a clue for you to do this now. I have colored the denominator red and e to the power of x dx in green. So what's the method of integration here? It's a simple substitution. What is a substitution? We substitute 1 plus e to the power of x equal to u and take the differential. The differential of the left hand side is e to the power of x dx equal to du. So when this becomes u, e to the power of x dx becomes du. I know this method must be now very familiar to you and you must now feel very comfortable doing it. So this will be limit b approaches infinity, integral 0 to b. I warn you, this limit is for x, not for u. But we just carry it. Once we finish the integration, we can replace u by, in terms of x, u by this quantity, and then apply the limit. So this 0 to b does not apply to u, although you can say u is a function of x. Alright, now integral 1 over u du is ln of u. So that will be limit b goes to infinity, ln u, and the limit goes from 0 to b. Remember, the limit goes from 0 to b for x. So we first of all replace u by 1 plus e to the power of x. So that will be limit b goes to infinity, ln 1 plus e to the power of x from 0 to infinity. Alright, replace the upper limit. That will give you, when x is replaced by b, e to the power of b, what is limit b goes to infinity e to the power of b? Well, that is infinity. So the upper limit is ln infinity minus the lower limit is when x is replaced by 0, e to the power of 0 is 1, 1 plus 1 is 2. So the upper limit is ln of 1 plus e to the power of infinity, which is ln e to the power of infinity, ln infinity minus ln 2. Now, do we have a proper value for that integral? No. Therefore, what kind of an integral is this? This is a diverging improper integral. That's right. Okay, another one. Determine if integral 0 to e ln x dx converges or diverges. Well, I think I gave it away already. I just showed it to you in the beginning of the class. Do you remember that? All right, let's work with it. Integral 0 to e ln x dx can be written as, why is this improper anyway? Because ln x is undefined at x equal to 0. Therefore, we take the limit when b approaches 0. Is that right? So this is replaced as limit b approaches 0, integral b to e. I hope you understand how we take the limit. The limit is taken wherever either the function is not defined or there is an infinity for the limit. Here, at x equal to 0, the function is undefined. So we take the limit when b approaches that value. So this will be limit b approaches 0, integral b to e of ln x dx. Well, now you know how to integrate ln x dx. You use integration by parts. U is ln x, du is 1 over x dx. Our dv is dx, therefore our v is x. And what is that integral therefore? Integral u dv is u times v minus integral v du. So let's write that down. Limit b approaches 0, integral b to e of ln x dx now equal to limit b approaches 0. Now, what's the integral? U times v x ln x minus integral b to e v du x times 1 over dx, and x cancels. So that will be limit b approaches 0, x ln x minus x, is that right? X ln x minus integral of x. This quantity will be integral of dx, which will be x. And the limit is for that whole quantity. So that will be x ln x minus x. Lower limit is b, the upper limit is e. Alright, we need to find the limit when b goes to 0. So first let's apply the limits. That will be limit b approaches 0, upper limit is e. So x ln e minus the lower limit is b ln b minus b. Alright. Now we take the limit. What is the value of the second parenthesis here when b approaches 0? Replace b by 0. When b is 0, this will go to 0. Therefore, the limit will simply be this. What is that value? What is ln of e? Ln of e is 1. So this will be e minus e, and that will be 0. So the value of this improper integral is 0, and that means it is a converging improper integral. That's right. Okay, another one. Determine if integral 0 to 2 of 1 over square root 4